Hello and welcome to another episode of Modular in a Week. In the last episode I said was the last episode of doing something with the Baby 8. And it is. We're not going to do anything with the Baby 8. I'm still going to talk about the Baby 8 because one of the flaws that you might have seen in the last video with cascading to Baby 8s is that I had to or did play one oscillator on each sequencer. So one sequencer played one oscillator and the other one played another one. And this is because you got two CV outs. What you could do, you could put them in a mixer and mix them together, but they always hold the last tone or note of each sequence, so that kind of messes up. Then you would have to mix the signal of the second sequencer so it matches, adds up to the first sequence last note, if you understand what I mean. So I'd like to switch between these two. I'd like to take those two signals out and then just use one signal and then the other signal. So today we're going to make a gated switch. And we're talking about sequencers on day 10 on this day, and I still think this is good in a sequence kind of way, because you can use this gate to sequence where and when a signal should go somewhere, which is a very useful thing. And we're going to do this with the 4066. It's a CMOS chip that I have talked about before, and I've made a small simple schematics that we're going to build, and we're going to see what we can make with this module. Hopefully we can do a lot with it. I'd like to say thank you to my patrons who, by being my patrons, support my work with this and everything else. And there's a few things, extra perks that they get over on Patreon. So if you want to see more of me and this and what I do, head over there and check some of that out, maybe. But let's sit down, solder this together, and let's look what we can do with it. Alright, so this circuit is quite easy and quite a small part count. We start over here. We have the 4 comparators in a TL074 with 10K and 100K for the about 1 volt comparator threshold. We have 4 diodes and then a bunch of 1K resistors throughout, so there's 3 1K resistors for each row, like this. We have 4 BC549, and these act like inverters. So these are actually inverters built with a transistor, and that's just to, so I didn't want to put a whole chip in, so I just added these 4, and that is so that you get the signal in on the base pin. And so if you have a signal, then the voltage plus on pin 1 or on pin on the collector is going to ground. Otherwise, if there's no input on the base, then there's voltage going out. So to make this circuit much more interesting, I added a switch between the inverter and the non-inverted input. So this means that when the control signal that goes out here and lights an LED if it's on or off, is either the switch is pressed, if we say that, pressed when there is a gate, or it is pressed when there's not a gate. So that's why we use the inverter here. So that means that we can switch the way it acts on gates. Another thing that you can't see in the schematics is that these gates, I have normally coupled these so they're all connected together, so when I connect a cable into gate A, it is also connected to all B, C and D gates if there's not another cable in here. So it's those normally connected jacks here. And that's because that way you can take one of these switches and put it to gate on is the on switch, or when the gate is high, and the other one when the gate is low. That means that it will, with one signal, it will switch between these two. I'll show that in the examples in a bit. So anyway, all these 4 lines then go into a 4066, which is very simply just the switches that goes one in and one out, and then the control signal. So when we get the control signal, we get a signal over the 2 pins of the switch. That's all there is to this circuit. Here's the final module with the panel, and so this was a little bit too tight. I couldn't fit the extra support on the back that keeps it rigid, so that actually sticks out a millimeter or 2, and yeah, it's just on the edge and really difficult to get all these jacks to fit. I actually came up with a way of just soldering the ground together between these two because they're so close. So you see the blob up here really makes it difficult for them to fit together. But yeah, and the proto board looks like this. I'll try to make a layout that you can follow. It's really easy to make it on this board. You just make 4 of the inverters there, and the comparator up top, and then the 4066 down there, and just a few diodes and 1K resistor, so nothing much. Alright, I just placed it here temporarily just to show a few features in relation to the Baby 8. I only have 2 of the gates here. I could add another one, I guess, but for this demonstration I only need 2. What we do need is we need to use the passive multiple all out. We need to use it fully. So for this to work now, to use both these Baby 8 sequencers to control one VCO, we need the first we need to split the clock signal to both sequencers. We can use 2 different clocks, of course, but in this case we do that. Then we need to take the cascade out from the first one, and we need to split that into 2, and 1 of course goes into cascade in on the second one, and the second goes to the gate input of the first switch. And then we need the second one, so the cascade out from the second one, we need to split that one, and 1 goes into cascade in on the first sequencer, and the second one goes into the second gate of the gate controlled switch. And then we have both the outputs from the CV. We take one into the first gated signal, so this is in the switch path and this is in the other one, and then we need to take both of those out of this, and then we need to actually use the passive multiple in reverse. So we take those two both in, and this is the Niklas Rönnberg passive multiple, so that's why as soon as we put a cable on the left side it breaks the connection upwards, otherwise it just multiplies all the way from up down. But so every time we add a new one we divide it, so that's why we actually get 4 passive multiples here. And the last one is used in reverse, so we take those two, that just goes into one, and then that one goes into our CV. So what this does now is that it switches between these two and opens up either that CV or that CV. So we only have one CV signal, and when we start the sound, so now we only have a full, there's no CV at all, and that's probably because we have it in the switch is, so when it's high it's off and low it's on. So if we do like so, and now we have it. I added the break-in jack, and here you can see with just one gate in, I can, by setting one in the low on and one in the high on, it switches between the two. I can of course switch both on at the same time or both off at the same time, or like that, same thing. So this is a good alteration if you don't want to use them just as a on-off switch with the switch. Another way to use it, maybe not as nice, but it's possible. You can use it as a really rudimentary VCA or gate as such. So here I have the tap looper as the gate input, and the CV going into VCO, and then through this one as a VCA. So it just opens and closes the signal path. And this can be done with any kind of sound. And to show you that you can use any signal, here's a old cassette player with the, where I have the tuner on for the radio, which for the life of me I can't get a good signal on any channel. But I route that through this one, and now we can control that signal. So it works with any kind of signal. So that's good to know, that both audio and CV signals works. So in this patch I have the sound from the VCO going into these two switches. One goes to the EFM Moog High Pass VCF that is controlled with LFO. The other one goes into the MS20 OTA filter. And here we have the OTA filter is just connected now and then. And that concludes this module. We now have a quite versatile switching module that you can control with gates, or if you pull the gate out you can control it with just the switches. And by using normally connected jacks for the gate input, we can also with one signal control many signals at once, and switching between two signals with one gate. So yeah, another switch type of sequencer we need, or I need, is a sequential switch, and I'll look at that in the next episode, I believe. And yeah, so make sure you are subscribing and you've hit the bell button so you don't miss that video. I try to do all these videos as premieres when I put them online. That gives me the opportunity to answer some questions immediately. So if you watch this after it's not a premiere, you can always look at the chat replay, and then you can see some extra things that I figure out once I am done with the post-production as well. Usually I have footnotes with things that I don't remember in the video that I add in the post-production, and then in the chat replay there's even more. And of course always in the comments leave your questions and thoughts there, and I'll try to answer them as good as I can. Until the next episode, take care, bye.